Hello, I'm Rob Cheesy from the Solutions Design team in ETAS Mobility Service Solutions. Today in this video, we'll take a look at our integrated diagnostic and repair solution for the fuel cell powered truck. Okay, let's set the context. I'd like to describe the solution known as GradeX Mobile. The first step is the development of diagnostic tests by our customer after-sales authors using our authoring tool. Once the tests are ready, we publish these into the GradeX application, used in workshops by our OEM customer technicians to diagnose the truck. The final part concerns feedback. This is obtained automatically by our ETAS data science team, and it is used to drive improvements to both the fuel cell ECU and GradeX workshop tester. Let me give you some background concerning this particular project. Typically, the after-sales diagnostic tester is created after the engineering of the product itself, in this case the fuel cell linked to the vehicle. The requirements and specifications for this system are cascaded to the after-sales department. However, this approach may not achieve the best after-sales diagnostic outcome. As an example, the ECU specification data may be incomplete, and when the after-sales team develop their diagnostic and repair methods, access to the design teams with the knowledge may be limited or not even possible. That can leave gaps and result in poor diagnostic coverage of the system. This project proved, by considering after-sales diagnostic development early in the life cycle, we can simultaneously develop both ECU and off-board tester diagnostic features. We also integrate diagnostic and vehicle information into a single application, removing the often disjointed approach of having data and content in separate tools. Our goal here is to provide a seamless experience for the workshop technician. Now let's look at the GradeX Mobile integrated diagnostic solution. GradeX Mobile is a cloud-based diagnostic solution requiring an internet connection. We can log in with a single sign-on, in this example, the Bosch single sign-on. Of course, we can customize this to a customer single sign-on. After sign-in, we come to the vehicle identification page. Here we choose the connection method to the truck, the VCI, which stands for the Vehicle Communication Interface. In this example, we're using our GradeX validation simulation interface. This is basically a diagnostic simulation of the truck misbehavior. If you wish to learn more about this, we have another product video in development. Please subscribe to our YouTube channel if you would like to learn more about the simulation approach. Here we see in this truck there are 4 faults logged in the electronic control unit of the fuel cell. A key introduction topic is the display of only the needed information to the technician. Here we can navigate from the fault description to the relevant active schematic wiring diagram. This supports the technician in their diagnostic activity. We can navigate and see which other electrical connections and components are linked to the fault within the active schematic tool. This really helps the technician localize the fault condition. Today, we won't go into the full details for the active schematic approach. That's a topic for another session. The key takeaway is the integration, then display of only the relevant information. Within GradeX Mobile, we can easily navigate back to the faults, where we are able to access troubleshooting guides associated with each fault condition. This is a troubleshooting sequence. It's created in an industry standard format called OTX, which stands for Open Test Exchange. Here, authors create diagnostic troubleshooting using suitable interface display types. Here we see a dynamic screen type. It shows real-time data obtained from the vehicle and then determines actions depending on the received result. Okay, let's pause the troubleshooting here and take a look at how these sequences are created using the authoring application. Now we know how this is created, let's return to the troubleshooting sequence. As this reading is in the red, we need to perform some further testing. Once more, we see an integration with the active schematic solution. Continuing with the test, we determine the wiring is good. Now, let's check the sensor. The sensor indicates an out of range value, meaning a faulty sensor requiring replacement. The technician now needs guidance on replacing the sensor, and without leaving the application, we bring up the appropriate workshop manual instruction. As a final step, we run a routine in the fuel cell ECU to confirm the fault has been fixed. This is the end of the demo showing the integrated diagnostic and repair solution. So that brings us to the end of this video on the fuel cell diagnostic and repair solution. What we did is show you how it's possible to create and publish diagnostic troubleshooting sequences for use by technicians with supporting repair information. Many thanks for watching. I hope you found this useful. If you'd like to know more, please subscribe to our YouTube channel.